Hello everyone. So today we'll be discussing about some conceptual problems of solid geometry. Since we have been reading solid geometry since our junior level, the concept about square, rectangle, and its extended form as cuboid, cube, right? So uh, even our high school problems, they include some concepts about solid geometry. So today I have 10 conceptual problems that can help you in your entrance examination. I would like to start from first one. So here in this problem, in the rectangular solid shown, if AB equals to 4, BC equals to 3 and BF equals to 12, what is the perimeter of triangle EDB, right? So we have option 27.33, 28.40, 29.20, 29.50, and 30.37. So as you can see this problem, so there are three face diagonals, which are the three sides of the triangle EDB as shown in a figure. So you need to find the perimeter of this triangle EDB as shown in the figure, right? Cuboid ABFEHG, right? CD. So there are altogether four faces, right? Four faces sidewise, and two faces at top and bottom of this cuboid. So here, let's start its solution. So what I did was, as our question suggested, that BF, AB, and BC are 12, 4, 3 respectively, right? Here sides of triangle are diagonals of three solid faces, right? Each diagonals are the face diagonals of the solid faces, as we can see in the figure. So I have splitted these three particular faces into three individual figures so that you can understand easily. But from this main figure, we can build the concept that BF is equals to AE and AB is equal to EF, right? So opposite sides can be equal, like BF equals to AE, AB equals to DC equals to HG equals to EF. So this is a simple basic property of cuboid as shown in figure. Since it has different sides AB and BF, they are different, so we can assume, or we can conclude, not assume, we can conclude that this figure is cuboid. So when you take for first diagonal DE, you can see, so DAEH is your face, right? DAEH, it's your face. And when DE is the diagonal that we have to find in this face, so you can calculate it by using Pythagorean theorem. So DE becomes your hypotenuse because it's opposite of the 90 degree, that is angle A. So DE becomes AD square plus A square. So when you calculate, you can find the value of D, that is 12.37. So when you are done with the face DAEH, so it's turned for BE, right? This BE, and it's the base of the cuboid. It's rectangular base of the cuboid, and its diagonal can be found by the process if you only take this base of the surface, right? Surface of the cuboid, that is A, B, F, and E. So when you break this figure into three individual parts, three individual faces are dealt here individually. So that is BE, right? You need to find BE, so you can use Pythagoras theorem as same as for DE, so that BE equals to square root BF square plus EF square, and the BF is equals to 12 and EF it's equals to 4, right? So when you take a square root, then you apply Pythagoras theorem, so its value is 12.65. So similarly, the only diagonal that isn't major is DB, right? DB. It's not measured yet. So when you take the face DABC, you can find the value of DB similar to this both D and BE side, right? So when you individually take out the side D, A, B, and C, so here D, A, B, and C, so we need to find the diagonal DB. So when you use Pythagoras theorem, because it's rectangular, side D, A, B, C, it's rectangular. So your one side is 3, one side is 4, and angle between them is 90 degrees since it's the face of cuboid, and that's why when you use Pythagoras theorem, it will come 5, right? So our question has asked us to find the perimeter of the triangle, which is formed by 3 diagonals, right? 3 diagonals are the 3 sides of the triangle, arc triangle DBE. So when you add these 3 diagonals, you get the perimeter of the triangle, that is 30.02, right? So it's option E, right? So I have calculated some points are missing, but the answer is D, that is 30.37. It's nearest answer. So this is for the question number 1. Okay, so here is the another question. In the cube shown above with the side S, what is the area of the plane inside the cube defined by D, E, and G? Right? So in the cube shown above with the side S, what is the area of the plane inside a cube defined by D, E, and G? Right? So the options are here A, B, C, D, E, right? You need to find the plane, right? You need to find the plane inside the cube, and the plane defined is connected to the point D, E, and Z. You need to find that, right? So let's see its solution. So when you take a cube, the difference between cube and cuboid is that all the sides, right, all the faces, they are equal, they have equal area. It's cube, right? Length, breadth, and height of the cube, they are equal, right? Basically, when the square is multiplied, or when you take a square, simple basic square in a 3D shape with an equal length and breadth, right? Height is equal to its length and breadth, then you can get cube. So according to question, the plane formed by joining D, G, and E will yield you to the triangle E, D, and G. So I have already drawn that 3 sides, they are equal, but you can't know just by drawing the figure. So you need to calculate each DE, DZ, and EG, right? You need to calculate all these 3 sides, which are the diagonal of the side ED, and this one point I have forgot to give this point name. So AD, let's say H, right? H is missing. If we consider this point as H, then AEHD, right? This is the square face since it's cube, and all the faces, they're equal. So obviously the diagonal, right, face diagonal of AEHD, EH, DEGF, right, and DHGC. All the face diagonals of these three faces, they must be equal since it's cube, right? It's simple concept. So since the figure in the cube and has a side of length s, right? So I estimated that the question has mentioned, I guess. So yeah, question has mentioned that each side is of s, right? So I supposed, right, just to make sure, but in exam you don't have to make sure, you just need to calculate the answer. But since I'm explaining this question, so let's be sure either we can suppose the value of s as 2 and solve this problem. So each side of triangle DEG is a diagonal of a square with a side length 2. So I suppose that value of s can be s equals to 2. So each side of triangle DEG is a diagonal of the square with side length 2. So if the side is 2, if I suppose that s is 2, then let's take simply this base, right, base surface of this tube DCG, and I suppose this as h since I missed naming this point. So you can write that DC and CZ, they are equal, and I have supposed this as 2. So the hypotenuse, the value of hypotenuse will be right 2 square plus 2 square whole square root, right? If you suppose s equals to 2, then both sides they are 2. So when you use Pythagoras theorem, that is 2 square plus 2 square, that is 2 root 2, right? You'll get the value 2 root 2. It will become root 8. So when you take HCF of 8, then I think the 4 will be the square root of 4 will be 2. So since 2 comes out and still there is 2 left in the square root, so it will become 2 root 2, right? So you can say that DZ equals to EZ equals to 2 root 2, right? So from that case, you can determine that triangle DEG is equilateral triangle, right? This is equilateral triangle since all the diagonals of this, all the face diagonals of all the surface, right, is equal in the cube, right? And that's the theory. So when I calculate the area of equilateral triangle, that is root 3 upon 4 a square, and my value of a is the side of the equilateral triangle, that is 2 root 2, the root 3 upon 4, 2 root 2 whole square, will give you the value of 2 root 3. So I just checked the value of s as 2 and did this calculation. But to be quick, right, now we have the concept that DE, DZ, and EZ are equal, and if the side is s, then it will be s whole square root s square plus s square. That will give you s root 2 or root 2s as your side, right, as the face diagonal of each face. That will be s root 2. So when you have one of the side of the equilateral triangle, so area can be calculated as root 3 by 4 a square, right? In place of a, I wrote s root 2 whole square. So when you calculate s root 2 whole square, that will be s square, and when you can cut the square root and square, that will become 2, right? And 2 and 4 can be cut into 2 ones and 2 twos are 4. That will be root 3 by 2 s square, right? So when you look at the option, right, B is the correct answer. So root 3 by root 3 upon 2 s square, right? So it satisfies our answer, and this is the picture you need to build up in your mind if the question about cube and it's related to the joining of three faces which are given in the joining the three face diagonals and make it making it in a single equilateral triangle, right? So this is about the question of equilateral triangle concept in the cube. So here is the another question that is that says that a sphere of radius 1 is totally submerged in a cylindrical tank of radius 4 as shown. The water level in the tank rises a distance of h. So what is the value of h? So you can see that the spherical ball is given, all right, and its radius is 1, right? It said that when the ball drops in the water level circular tank, it is submerged there in the cylindrical tank, and whose radius is 4 as shown. So water level in the tank rises a distance of h. So when this ball is submerged in the water, then obviously the water level will rise in the cylindrical tank since the volume is raised, right? The volume of sphere will make a difference in height of the right rise in a level of water in the cylindrical tank as shown in the figure. So how will you take out the height of h? That is asked in this question. So what is the value of h? Basically the h means the height that gets rise when the spherical ball is submerged in the cylindrical tank. So how will you take out the new value, right? The value of h which gets rise when the cylindrical ball is submerged in the cylindrical tank. So you have the option that is 0.072, 0.083, 0.096, 0.108, 0.123. So here is another pictorial representation when the spherical, right? The spherical ball, when it gets submerged in the cylindrical tank, then it's obviously our estimation is that there is little bit rise in the water level of this cylindrical tank, and I supposed it as h, right? This orange part, I sketched it for the value of h, or the rise in height of the water level in this cylindrical tank. So sphere has a volume v equals to 4.9. Question has mentioned it, right? We uh, we know that the volume of the sphere is 4.19. So when submerged, it will push up a layer of water having equal volume, right? So when you throw this ball in this cylindrical tank, then it obviously occupies the volume, right? Volume in a cylindrical tank, same as the volume it has in the air, right? But this occupied volume will make an effect in the water level, and the water level it gets rise, and the value of h, right? This new height, right? The height that gets I have mentioned this new height label, right? So when it gets submerged, a layer of water having equal volume, that the volume of this sphere will make an effect, and there's a little bit rise in the cylinder water level in the cylinder, right? So this height can be calculated as the volume of this water or increased layer of water is, right? The volume can be calculated by area of cylinder's circular face and the multiplied by the height to which it lifted, right? This height is due to the presence of the spherical ball that gets submerged in the cylindrical tank, right? The water level rises and there is slightly change in the height of the water level. So for that, uh, for to take out to find this value of h, we need to find the volume of the water, right, that has rise, and it has been shown in this colored part, that is orange colored part, shaded part in the figure. So area of cylinder's circular surface, when you multiply it by the height to which it lifted, I suppose it as h, then area of cylinder's circular surface is pi r square, right? This surface is pi r square, and when you multiply it by this height, then you will get the volume, this volume of the shaded part, the volume of the water that has risen than its initial level, right? So you'll get that value. So for that, it's simple. We know that the volume occupied, right? We already know that the spherical ball has the volume 4.19. So when you get submerged, then the new height or the change in this height and its volume is gonna be 4.19. So when you multiply it by pi r square into h, and then you can equate it with 4.19. So we know that pi r square, the value of pi r square is the radius of the cylinder is given 4 in this question. So when you take out the circular surface area of the cylindrical tank, then that would be pi r square, pi dot 4 square. When you calculate it, it will come 50.27. So that will be pi r square into h equals to 4.19. Right, so 50.27 into h equals to 4.19. That will be, the height will be 0.03. When you divide 4.19 divided by 0.27, then you'll get height 0.083. So you can calculate the height due to the submerge of the cylindrical ball in the spherical ball in the cylindrical tank, right? So when you check the answer, it will be B, that is 0.083. So here's another question that says that a rectangular solid is inscribed in a sphere as shown. If the dimension of the solid are 3, 4, and 6, then what is the radius of the sphere? So the options are 2.49, 3.91, 4.16, 5.62, and 7.81. All right, so question, it has mentioned that rectangular solid, right? The rectangular solid, that means cuboid, is inscribed in a sphere as shown in figure. So on the dimension of solid 3, 4, and 6. So when these kinds of dimension are given, then we need to care, or we need to keep some concepts in our mind that length, breadth, and height of the cuboid is given in the question, right? The dimension of solid 3 is the length, and 4 can be breadth, and the 6 can be height, right? Length, breadth, and height of the cuboid which is inscribed in the sphere, it's given, right? So you can take out the volume, right? So you can take out the volume of the cuboid inside the sphere, right? So what is the radius of the sphere? The question has asked that what is the radius of the sphere. So the picture is picture can be a little bit unclear, so I just drew it to make you so that you can get the concept, and because there is a little bit concept about inscribed solid, right? So inscribed solid can be when the cylinder can inscribe the sphere, or cylinder can inscribe the cone, or sphere can inscribe the cone. So in this case, the sphere has inscribed the cuboid, and it has asked the diameter of the sphere, right? So the concept is that the logic of the question, if the cuboid is given and it's inscribed in a sphere, the main logic about this inscribed solid geometry question is that when a cuboid rectangular solid is inscribed in a sphere, the diagonal, right? The diagonal of that solid, right? The diagonal means the body diagonal, right? Body, sorry. Yeah, it's body diagonal, not a face diagonal, or it can be said as the longest diagonal of the solid, rectangular solid. The body diagonal of that solid is equal to the diameter of the sphere. So you can know that if any rectangular solid is inscribed in the sphere, then the diameter of the sphere can be calculated or can be said as equal to the body diagonal of the rectangular solid inscribed inside the sphere. So for that, you need to have a concept of super Pythagorean theorem. So super Pythagorean theorem tells you that if you are given the length, breadth, and height of the rectangular solid includes cube and cuboid, then you can take out the body diagonal by using the super Pythagorean theorem. You just have to find the value of diagonal by square rooting the length square plus breadth square plus z square. So if this is one of the corner of the rectangular solid as shown in a figure. Let's suppose this is the corner of the figure here. So if this is the corner, then length, breadth, and height, using length, breadth, and height, you can calculate the body diagonal of the cuboid, that is x square plus y square plus z square, or length square plus breadth square equals to height square. So that is given by 3 square plus 4 square plus 6 square. So when you calculate it, you'll get the value of 7.8102. So question has asked not a diagonal, right? Sorry, not a diameter, but it has asked the radius of the rectangular solid. So when you divide the diameter with, right, 2, because twice in the radius will yield you a diameter. So when you divide the diameter by 2, then the value will appear as 3.91, and this is the radius of the sphere, right? So by the concept of super Pythagorean theorem, you can calculate the diameter of the sphere, because when the rectangular solid is inscribed in a sphere, then the body diagonal of the rectangular uh, rectangular solid will be equal to the diameter of the sphere. So this is the logic, right? So you can calculate the radius of the sphere by dividing diameter by 2. You can get the radius. So here is the another question, that is, a cylinder is inscribed in a cube with an edge of length 2, right? What volume of space is enclosed by the cube but not by the cylinder? A cylinder is inscribed in a cube with an edge of length 2, what volume of space is enclosed by the cube but not by the cylinder? So your options are 1.41, 1.56, 1.72, and 3.81 and 4.86. So here's the question. And this time, cylinder, it's inscribed in a cube, right? A cube has the age, the value of age, that is 2. That means length, breadth, and height of the cube is 2. Then obviously, when the cylinder is inscribed in a cube, then the base, right? Base of this cylinder, it's completely inscribed in the cube, right? Making each edge of the cube at its tangent, so that the diameter will be equal to one of the edge of the cube. So from that you can determine that obviously the radius of the cylinder, or the radius of the base of the cylinder, will be 1, right? Because it can be said equal the diameter of this uh, area of the base of the cylinder and the age of the cube. They are equal, right? So we need to find the radius of the cylinder, which is 1, because the value of age is 2, and when you divide diameter by 2, then you will get radius. So I marked the radius of the cylinder as 1, right, from the figure. So you can calculate the volume of the cube. So volume of the cube, the formula for the volume of the cube is, that is L cube. So obviously 2 cube will give you 8, so volume of cube is 8, right? So what is the height of the cylinder? The height of the cylinder is obviously same to the height of the cube, that is 2. So what is the radius of cylinder? I told you that it's diameter divided by 2. So since the diameter and the age of the cube, they are equal, so the radius will obviously be 1, right, as shown in the figure. So volume of a cylinder, we can get the volume of cylinder by r square. Yeah, so the value of r is 1, pi as it is, and value of h is 2 when you calculate it. So volume of cylinder, right, the cylindrical part, the volume of the cylinder part is 6.28. So question has asked the difference, right? Or it has asked you the volume of space enclosed by a cube but not by a cylinder. So for that volume, it has asked the red colored part right inside the cube. So you just need to find the difference between the volume of the cube and the volume of the cylinder, right? So you can get the space inside the cube that isn't enclosed by the cylinder, right? So you need to find the difference between the volume. So difference is 8 minus 6.28. That is 1.72. Right? 1.72.